Hey, Kipsters, welcome to our skill practice for today, Friday, January 15th. As you can see, this is going to be based off our lesson 2 that we did on Wednesday on our math expression structure. So real quickly, just go over our objective. We will be able to describe, mathematicians will be able to describe the structure of an expression in terms of a context using mathematical terms. And realistically, what we're actually be focusing on is describe the structure of an expression. That's going to be our main focus today. To be able to take an expression, look at its structure, and identify each piece of that structure. So real quick, just to give you like a preview of what this will look like. This is an expression here that's actually an equation because it has an equal sign, but we'll be doing something very similar to this. And we will identify the coefficient, the variable, the operator, and the constants if they are in the expression. So this is what you will be doing in our independent practice for today and in our lesson today. So the first thing we need to be able to do is identify terms. Now, what is a term, right? I know there was some confusion before as to what a term could be. So we're going to spend most of this lesson really focusing on what a term is. So here you can see the definition. A term is either a single number or a variable or numbers and variables multiplied together or grouped, separated by an operator. Well, then that brings the next question. Well, what is an operator? Let's look at what that is. An operator, as you see down here, is a symbol such as the plus sign, the multiplication sign, subtraction, division sign that shows an operation. We want to do something with that. So what are we going to do? What math are we doing? We think about an operator, it's the math that we're doing. And I just want to make a quick note that for the purposes of today, my camera gets turning on. For the purpose of today, when we talk about the multiplication symbol, we're no longer going to use it as you see here. It's actually going to be represented by a little dot like this. And the reason for that is that the multiplication symbol looks a lot like the variable x. We want to make sure that we don't get those confused. So from here on out, you'll see a multiplication symbol presented like this as a dot, just so that we are aware. So for us to identify terms, we first need to identify the operator. Well, if you look at here, I know that my operator is this plus sign. It's the operation that we're doing. We are adding. Well, what are we adding? Well, we're going to add this 7n and this 4. But notice how in this expression, I have two terms. I have this 7n that's being added to the 4. Now we'll get more into like what this 7n means, but for the purposes of just terms, we group this 7n together. It is actually combined. It is 7n. It is not 7 and n. It is 7n together, which is why it's a term by itself. You will see some more examples of like different types of groupings that'll also be considered a term on their own. So let's do some more practice. So here we have the expression 5 minus 3b. How many terms does this expression have? Well, the first thing we need to do, we should definitely identify the operator. So the operator I see here is this minus sign. So I know that then my terms are this 5 by itself and this 3b, which means that we have two terms. Another expression. All right, so we want to identify how many terms are in this expression. Parentheses 4 minus 2, parentheses plus 3y. First thing I want to identify the operator. And the one thing we may notice, and I'll point this out here in a second, is that there's technically two operators that I see. I see this minus sign here. I see this plus sign here. One thing we want to be careful with is this being considered an operator. And the reason for that is what you should have noticed is that this expression right here, this is expression by itself, is actually grouped together. The parentheses groups this together and actually makes it one term. So we don't really have to focus on this operator because the parentheses actually groups it together. So the actual operator is just this plus sign, which means that this entire grouping right here, 4 minus 2, is one term. And this over here is a term on its own too. So actually, I only have two terms. And once again, the reason for that is because this right here is grouped. So we look at it as just one thing, not as separate parts. It's not 4 minus 2, it's 4 minus 2 all grouped together, which is why it's a term. The grouping here, the parentheses, makes it look at it's just one term. So anytime you see a grouping, you got to be very careful because that actually tells you that it's a term by itself. All right, I want you to go ahead and pause the video here. Try to figure out how many terms are in this expression. Once again, our initial step here is to identify the operators in our expression. So I have one operator here, it's the addition sign, and another operator with the subtraction sign. I don't see any groupings here. There's no parentheses. And I do see this grouping here of 7m and 3y. So these are single terms on their own. So I can underline my terms. I have one term here. I have one term here. I have one term here, all separated by operators, which means I actually have 3 terms in this expression. So this is the first part for us to break up expressions by their structure, by their components. So we first need to, 1, identify how many terms are in our expression. Now we're going to actually have to understand what some of these terms mean. So in order for us to identify the components or parts of an expression, we need to understand what's going on in our expression. So what's actually happening. And here's a really key point. Anytime you see a number next to a variable, that represents multiplication. For example, if I have if my thing works, there we go. There we go. If I have a variable next to a number like this, let's say it's 4w. What that actually represents is 4 times w. I remember we're using that dot now as a symbol for multiplication. So that got confused with the variable x. So 4w actually means 4 times w. So when I look at my expression here, what actually is going on is I can go ahead and break this up into 7n means 7 times n plus 4. But we need to understand that actually this means multiplication. It doesn't change how many terms we actually see because when you're identifying terms, you use your original expression. Here's my operator, and I have 2 terms, the 7n and the 4. But for us to understand what's actually happening, we actually need to understand that 7n means 7 times n. So this is what's called expanding our expression so that we know exactly what's going on. So in this case here, I have this 4z actually represents 4 times z. And then go ahead and try this. How do I split up 6y? That is correct. 6y is actually 6 times y. Not only are we going to be able to identify terms, we'll be able to break up our expressions and expand them to represent what's actually happening, what are we actually doing. And this will help us better identify the different parts to our expression based on what we see here. So keep this in mind as we go into the next part and we really go into details of how to identify the different parts of our expressions. So here is our expression structure here. So our goal is to, 1, identify how many terms on our expression. Well, once again, remember that in order to do this correctly, we got to first identify our operator or the operation that we're doing. And the really easy way to see this, if it lets me click, is once I identify the operator addition sign, what am I adding? I am adding the 7n plus the 4. Operator tells you what 2 values you're working with. And normally around an operator, you normally have 2 terms. You need 2 terms to actually do any operation. So I will know here that I have 2 terms. I want to expand my expression. And expanding my expression just allows me to see what's actually going on. So 7n expands to 7 times n. I'm adding to 4. It may help for you to group this up so that you know that this is a grouping. This is something you're doing together because it's a term by itself. So Parentheses helps you identify that 7n is the same as 7 times n. And once again, this is a grouping together, which is why it's a term by itself. So once we get to here, then we can actually start identifying the different parts of our expression. Well, let's look at this. The first thing after I expand my expression is to identify my variable. Well, what is a variable? You may be asking yourself. Well, a variable is a letter used to represent a number we don't know. And the key part about this is that it's a letter right here. That part is extremely important. Once we can identify that it's a letter, then we can go into our expression and look for, okay, well, what's the letter in this expression? Well, the letter in this expression is n. So I can identify that n right there, that's my variable. That is a letter that represents a number I don't know. It's still a number, even though it's part of the alphabet. It's still a number. This is some number that we don't know that we're using a letter to represent. So this is our variable. This can change. This n can be 2, it can be 5, it can be 10, it can be 1 million. It can be whatever number we decide it to be. That's why it's called a variable. Okay, so we identified the variable in our expression, which is n. Let's identify this other components. Our next thing to identify is the coefficient. And I know coefficient, we gave you a vocabulary or term definition yesterday, but I think this one makes a lot more sense. A coefficient is just the number you use to multiply a variable. Well, interesting. Well, what does that really mean? In other words, a coefficient is the number that you multiply a variable by. And we could easily see that because all you gotta look for is your variable and what it's being multiplied by. So here is our multiplication symbol. Remember, this means multiplication. Well, what is this n being multiplied by? I already identified the variable. It's being multiplied by 7. So this 7 right here is my coefficient. So there you go. I identified the variable, which is n. I identified the coefficient, which is 7. There's one more thing we need to identify. And that is our constant, number 5. A constant, a number that's on its own or doesn't change. A number that will always be by itself. It's not going to be attached to a variable. It's not going to be grouped up. It's a number that's by itself. And as you look at here, I have the only number that's by itself that has nothing attached to it is this number 4. So right now, this number 4, that is my constant. I can't spell, but that's my constant right here. So notice I have identified each part of this expression. I identified the n here as my variable, the number that can change. I identified the 7 as the number that's being multiplied to my variable. So 7 times n, that's why this is my coefficient. And I represented the constant, which is 4, the number that's on its own and it's not going to change. This 4 will not change no matter what. This term will change based on what n is. So that's why it's called a variable. Let's do some more practice on that to really, really ingrain as to what you're doing today for your work. So as you can see here, here are the different parts. I identified the variable, which is n, which is the letter. The coefficient number is being multiplied to the variable, which is 7. And the constant, which is the number that's by itself, it's not going to change, which is 4. This is what we're doing in today's work. And let's go through some examples. So I want to identify how many terms I have, the variable, the coefficient, and the constant. So for me to identify the terms of the expression, remember, we need to identify the operator. What math are you doing? And in this case, I am subtracting, which means I have 2 terms. As you can see, I have 12, which is 1 term, and I have 2w, which is a term on its own. So I have 2 terms. I want to go ahead and expand this expression. So I know 12 is going to stay the same. I'm not expanding that to anything. Minus this 2w, I can expand into 2 times w. So now I have my expanded expression. Let me make sure that dot is nice and clear. So 12 minus 2 times w is the expression that this represents up here. I need to find my variable, which is the letter. Well, let's look for the variable in this expression. And as I can see here, the variable in my expression is a letter. So it's the only letter I see is a w. There's my variable, is the w. My coefficient is a number that's being multiplied to the variable. Well, I know here's my multiplication symbol, here's a variable. What's being multiplied to the variable? Well, 2 is. I'm multiplying 2 times w. So 2 is my coefficient. And my constant is going to be a number that doesn't change. Well, which is the only number that's not going to be changed or that's on its own? And that number is 12. That's constant. It's always going to happen. So there is my 12. Let's do another model, and then we're going to have some time for you to do this on your own. So here I have the expression n minus 1. Okay, first thing I want to identify the terms. Once again, for me to identify the terms, I need to identify the operator or the math that I'm doing. That math will help me identify the terms. So I know I'm subtracting. As you can see here, here's my operator, my subtraction symbol. Well, what am I subtracting? Well, I'm subtracting this n and this 1. So notice how I underline my terms. I underline the n as a term and the 1 as a term. So how many terms do I see? Well, 1, 2. There's 2 terms here. And to expand my expression, well, as you can notice here, I actually don't have anything to expand. There's no number in front of here. Whenever there is nothing in front of my variable, you could always assume that the number in front is going to be 1. So technically this is 1 times n, because anything times 1 will give you the same answer. Anything times 1 will give you the same answer. Anytime it's by itself, which represents 1n. But we don't use that because it's no point. So anytime you see a variable by itself, it represents 1. 1 times n minus 1. So as we go through this, I look at this. What is my variable? Well, that's easy to see. My variable is n. It's the letter. What is my coefficient? In this case, my coefficient could be 1. An acceptable answer will also be 0. There is no coefficient if you look up here. But 1 is what you want to say because 1 is actually what this n represents. It's 1n, which you'll get more understanding as we work with letters in the future. An n by itself actually is just 1n. So it's 1 times n. And then what's the number that's by itself and doesn't change? Well, that's the 1. All right, let's see if you can do this on your own. This would be good practice before you get into your actual work. All right, so we have the expression 4x plus 32. Go ahead and pause this video and try to do this on your own on a piece of paper or a whiteboard to see if you can get this correct. All right, let's go through this. We're just going to quickly go through what this is while I explain. So identify the terms, look for my operator. My operator is the addition symbol. What am I adding? Well, I'm adding the 4x and the 32. So how many terms do I see? 1, 2. There's 2 terms there. When I expand my expression, is there anything to expand? Well, yes, this 4x actually means 4 times x plus 32. All right, let's go to the variable. What is my variable? Well, I'm looking for a letter used. Remember, this is why we use a multiplication symbol, because we want to confuse this x as a multiplication sign. This is actually x and not multiplication. So in this case, my variable is the x. It's the letter that represents a number. There's my x. My coefficient, well, I'm looking for a number that I'm multiplying to a variable. What am I multiplying to this x? Multiplying 4. Well, 4 is my coefficient. The constant is a number that's not going to change or doesn't move. It's by itself. And that 32 is by itself. That's my constant. So one more example. I have 22 plus 10z. Once again, pause the video here. Try this on your own so that we can go over this in a second. All right. Identify my terms. Look for my operator. I can see my operator already. It's this addition symbol here. This is my operator. What is it doing? What am I adding? Well, I'm adding the 22 and the 10z. So how many terms do I have? I have 2. Can I expand my expression? I most certainly can. 22 plus and times z. Oops, and I messed up. We're not using that multiplication symbol anymore because it's going to be confusing for x. 10 times z. There we go. Use that dot. What is my variable? It's the letter. In this case, the variable is z. What is the number that's going to be multiplied to my variable? What's the coefficient? That's 10, because I'm multiplying 10 times z. 10 times my variable is z. And then what is the number that is by itself that's not going to change? Well, it's that 22. So my constant is 22. So that is the work you'll be doing today. If you need more support, you can just skip to this last part of the video so that you can see again how this works and how you identify each part. This is going to be important because this is the language you're going to be using for the rest of this lesson. is we're going to be hearing terms, you're going to be hearing the word variable, coefficient, and constant. It's going to really just help shape your understanding of where they are and how they look in an expression. So this is really important for us to understand and really be successful in our later parts of the lesson. So at this point, it's your time to do your independent practice, and best of luck with that. I will see you all on Tuesday.